Chapter 1.6.7 Dynamic Volume Provisioning. Dynamic volume provisioning enables storage volumes to be generated as needed, eliminating the manual process of cluster administrators having to request new volumes from cloud or storage providers. This feature in Kubernetes allows for automatic provisioning of storage when users create persistent volume claim objects, eliminating the need for pre-provisioning by administrators. This simplifies the process and increases efficiency in managing storage resources within the cluster. Background. Dynamic volume provisioning in Kubernetes is implemented using the storage class API object from the storage.k8s.io group. Cluster administrators can create multiple storage class objects, each specifying a volume plugin and parameters for provisioning. This allows for different flavors of storage from various systems to be exposed within a cluster. End users are able to select from these options without needing to understand the intricacies of storage provisioning. More information on storage classes can be found at the provided link. Enabling dynamic provisioning. In order to enable dynamic provisioning in a cluster administrator must create one or more storage class objects for users. These objects specify which provisioner to use and the parameters to pass to that provisioner when dynamic provisioning is called. The name of a storage class object must be a valid DNS subdomain name. Two examples provided are creating a storage class slow for standard disk-like persistent disks and creating a storage class fast for SSD-like persistent disks. Using dynamic provisioning. In Kubernetes, users can request dynamically provisioned storage using the storage class name field in their persistent volume claim object. Prior to version 1.6, this was done using the volume.beta.kubernetes.io/storage class annotation, which is now deprecated. Users must now match the storage class name value with a configured storage class to provision storage, such as selecting the fast storage class to automatically create an SSD-like persistent disk. When the claim is deleted, the volume is also destroyed. Defaulting behavior. Dynamic provisioning can be enabled on a cluster by marking one storage class object as default and ensuring the default storage class admission controller is enabled on the API server. An administrator can mark a storage class as default by adding a specific annotation to it. When a user creates a persistent volume claim without specifying a storage class name, the default storage class admission controller automatically adds the field pointing to the default storage class. If multiple storage classes are marked as default, Kubernetes will use the most recently created default storage class. Topology awareness. Multi-zone clusters allow pods to be distributed across different zones within a region. To ensure efficient storage, single-zone storage backends should be provisioned in the same zones where pods are scheduled. This can be achieved by adjusting the volume binding mode,